Imagine a high-stress sales floor where every process is flat. Lead theft is rampant because anyone can access any file at any time. In computer science, this environment is a perfect representation of the old procedural language approach. The defining flaw of procedural programming is that it prioritizes functions, the execution of tasks, while leaving the raw data entirely unsecure. It gets the job done, but the client files are left exposed to anyone on the network. On a procedural sales floor, this lack of boundaries makes scale impossible. You don't just get faster as you grow, you get constant collisions as multiple representatives attempt to manipulate the same client data simultaneously. To solve these scalability problems, Bjorn Stroustrup developed C++ in 1980. His goal was to move beyond the limitations of older languages by creating object-oriented programming, a way to build software that is modular, secure, and ready for massive expansion. Surviving in a modern business environment requires moving past top-down procedural management. Long-term growth is achieved by rebuilding your team around the same logic found in object-oriented code. The first bottleneck to address is the hijacking of leads. On a flat floor with no internal boundaries, accounts are easily stolen because there is no mechanism to claim ownership. We fix this using classes and objects. The class acts as your master blueprint for an ideal salesperson, while the object is the actual living employee you instantiate from that blueprint to work on the floor. We secure their work through encapsulation. As this structural breakdown shows, C++ uses access specifiers to separate private data members from public functions. Inside the class, client lists are declared private, locked away, accessible only through public member functions, your officially approved pitches. Encapsulating data this way eliminates internal theft. Representatives can no longer fight over exposed resources because they are forced to interact with data through these designated, secure pathways. The second problem is the time wasted on promotion. Moving a representative to an enterprise role often feels like a total reset, requiring you to retrain them on basic skills they should already know. C++ manages a representative's lifecycle with built-in tools, the constructor for instant onboarding with baseline traits, and the destructor to cleanly wipe their access and resources if they leave the company. But for scaling knowledge, the real solution is inheritance. This is the architectural mechanism that allows a team to grow without creating redundant training programs. This diagram shows how a new derived class, like a manager, automatically inherits the proven skills and private data access of the base class representative. Using an inherited structure creates massive reusability. You define the successful traits of a salesperson once, then use them to rapidly expand into specialized tiers. Even a well-trained team can fail if they are stuck with a rigid sales script. When a script cannot bend to a client's specific needs, the deal usually breaks. To create a floor that is truly flexible, we implement polymorphism, specifically through a technique called function overloading. Function overloading allows you to use a single name for a function, like pitch, while providing multiple, distinct parameter lists for different scenarios. When a rep launches the pitch, the system automatically adapts its behavior based on the specific client parameters fed into it. This structural flexibility replaces a static script with a toolkit of situational responses, allowing a representative to pivot as soon as a client's profile changes. The final bottleneck happens when a representative hits a surprise objection. If they don't have a plan, they freeze up, and the interaction ends immediately. In programming, this is a runtime error. The code encounters an unexpected logical scenario and undergoes a hard crash, losing all progress. We prevent this termination by building in exception handling blocks as a safety net to keep the interaction alive. The logic is sequential. The rep tries the pitch, the client throws an objection, and the rep uses a catch block to pivot. While you cannot prevent every single objection, building your workflow with this architecture ensures that your team can survive those moments and maintain the deal. At this level, the sales floor functions as an integrated system where security, onboarding, and adaptability are properties of the workflow itself. The final layer is abstraction. This is the process of hiding all the complex internal machinery, the data members and access specifiers, from the outside world. Through abstraction, the client only sees a clean, simple interface. They experience a professional interaction, completely insulated from the underlying logic that makes the system work. Sustainable growth happens when institutional knowledge is inherited and objections are handled through standardized logic. The organization stops relying on individual stars and starts scaling through its own architecture.